Hi guys, I'm Nova Lopez, a BSTV student. So for today, we're gonna do an experiment comparing the densities of the hot water and the cold water. To start with, you'll need to prepare a stainless food warmer tray plate, 2 cups that are the same size, two different colors of food coloring, yellow for the cold water and violet for the hot water, a cut of plastic folder, a cold water, and lastly, the hot water. The first step is to fill up 1 cup with the hot water and the other one with the cold water, all the way to the very top where the water is actually above the top of the glass. And now, it's time to add your food coloring. What colors don't really matter, but for this experiment, we choose yellow for the cold water and violet for the hot water. At this point, it's time to take a cut of plastic cover and put it on top of the hot water glass. After that, you can flip it upside down. The air pressure in the room will keep it attached to the glass. This will allow you to place the hot water glass carefully on top of the cold water. And slide the piece of plastic out without spilling. This step doesn't always work out perfectly, so I would use a larger bowl or a sink to catch any water. You'll notice that the hot water and the cold water don't mix even though they are in contact with one another. That's because the density of the cold water has the particles packed a little closer together than the hot water, and gravity is pulling them down. Now it's time to repeat the experiment. Only this time, we're going to reverse it, so go ahead and fill up your cups with the hot water and the cold water again. And then, use the food coloring to make the cold water become yellow and the hot water become violet. Again, be careful lining up the cup and sliding the plastic out so that you don't make a mess. This time you'll see the cold water and the hot water start mixing quickly. This is because the higher density cold water starts falling down through the lower density. The hot water and the food coloring is taking along for the ride, so you can see it happening. Now, I am going to show you a video that is using thermal infrared camera. Video is not mine. Now, let's take a look at this experiment with a thermal infrared camera. It's important to note that thermal camera can see through glass. So what it's looking at is the temperature on the surface of our container, which is why there's a little bit of a delay when we pour our liquids into them. You'll notice that not only are the colors not mixing, but the temperature of the hot water stays hot and the temperature of the cold water stays cold. This part of the video is even speed up so that after 10 minutes, the temperature of hot water is still above 90 degrees and the temperature of the cold water is still below 65. Now, let's take a look at the other experiment with a thermal camera. The color starts mixing immediately, but if you look at the thermal camera, it shows that the hot water and the cold water don't just trade places. The hot water particles lose some of their heat energy to the cold water particles, and then after a minute, everything's the same temperature again. If you remember, there's a little bit of a delay because the thermal camera is looking at the temperature on the outside of the container. So thanks for watching, and I hope you learned something about the cold water and hot water experiment. And if you enjoyed this video, share it with your friends, and don't forget to like and click the bell button on YouTube. Thank you.